Hi students, have you forgotten partial fractions? If you have, please stay on. We're going to revisit all the rules that are needed to do partial fractions. So hang on. Right, supposing we're asked to express 1 minus x over x squared minus 5x plus 6 into partial fractions. Right, so how do you go about it? So very first thing is to observe the denominator. Okay, if you see the denominator is a quadratic expression, let's try to factorize it. Alright, and observe that we can actually factorize it into two linear factors. So if you're going to rewrite the fractions given, it will turn out to be 1 minus x over x minus 3 times x minus 2. Alright, so your denominator comprises of two linear factors. Right, so if that is the case, then how do we express it as partial fraction? So we're going to let it equals to a over the first linear factor, which is x minus 3, b over the second linear factor, that's x minus 2. Alright, so with these two fractions, we're going to combine them back into a single fractions. Combine them into back into a single fractions. And we're going to find the unknowns a and b. So how do we do it? Alright, so now you see that the denominators are the same. So now we can compare your numerator. Alright, so there are two unknowns there, a and b. So we're going to use the substitution method to eliminate one of them. Alright, so supposing if you're going to eliminate the constant a, right, to eliminate constant a, you just need to take a multiplied with a 0. Okay, because a times 0 will give you 0. So how do you get a 0 out from a bracket x minus 2? That is when you let x minus 2 equals to 0. So you substitute x equals to 2 to the above. And let's see what we have. Right, so when you substitute x equals to 2 to the above, you will see that we will have a bracket 2 minus 2, and that gives you 0. And that's exactly what we want to achieve. The next one will be just 2 minus 3 equals to 1 minus 2. Right, so you end up getting negative b equals to negative 1, so therefore b is equals to 1. So having found the answer for b, we're going to substitute it back into our identity. Right. So we would have a bracket x minus 2 plus b, it's 1. So just basically 1, 1 times bracket x minus 3 will just give you x minus 3 equals to 1 minus x. And then you can just use any other values for x to find the values of a, but not x equals to 2, right? So we're going to substitute, we're going to let x equals to 0. Let's see what happens. So 0 minus 2 gives you negative 2. 0 minus 3 will give you negative 3. 1 minus 0 will just be 1. So from here you get negative 2a minus 3 equals to 1. Negative 2a is equals to 1 plus 3, 4. A is equals to negative 2. So therefore the partial fractions will be right, so a it's negative 2, so it's just negative 2 over x minus 3. B it's 1, so plus 1 over x minus 2. Right, so basically this is how you do solve questions where the denominators comprises of two linear factors. Right, let's look at the second rule. Supposing you're asked to express 2 plus x over bracket 1 plus x to the power of 2 in partial fractions. Right, so that's exactly the denominator. So the denominator will comprises of repeated linear factors. So why is 1 plus x to the power of 2 considered as repeated linear factors? Basically, if you were just to break it up, it's just bracket 1 plus x multiplied with another 1 plus x. Hence, it's repeated in that sense. Okay, so what is the rule when you have a repeated linear factors? right, basically it will be just a over the first linear factor, which is 1 plus x, then plus b over the repeated linear factors. Alright, so we're going to combine. So what you have here are two partial fractions, which you're going to combine them into a single fractions. And how do you determine the denominator? It's actually very easy. Just look at the original fractions are given to you. The original fractions is given to you. The denominator is bracket 1 plus x to the power of 2. So that will be your denominator. Okay, when you want to combine the two partial fractions. Alright, so you look at the first partial fractions, okay. So your denominator only have one linear factor, that's 1 plus x. But you want it to be repeated, so you need to multiply with another linear factor. So that would be just a multiplied by 1 plus x. And then if you look at the second partial fractions, the denominator is already the repeated linear factors. So therefore, you just need to take b times 1, and b times 1 is just b. Okay, very good. So now we have the same denominator. We can just compare our numerator. And in this case here, it's we don't even need to do substitution methods. You can just open up the brackets, and we can just compare coefficients of similar terms on both sides. So we're just going to compare ax on the left with x, the x term on the right. So ax is equals to x, and you can just divide by x on both sides to get a equals to 1. Alright, and then we can just compare our constant term, which is a plus b on the left side equals to 2 on the right side. And after we found the values of a equals to 1, we can just substitute into a plus b to get 1 plus b equals to 2. And from there, b is equals to 1. Okay, great. So now we have found the values for a and b. We can just put it back into our partial fractions. So therefore, the partial fractions are just a over 1 plus x, which is just 1 over 1 plus x, plus b, which is also, we got it 1 also, so it's just plus 1 over bracket 1 plus x to the power of 2. Okay, this is how we do it. Alright, so let's look at the third situation, where what you're given is, let's say, supposing express 1 minus 2x over x squared plus 4 in partial fractions. Alright, so if you look at the denominator, x squared plus 1 is considered irreducible. Okay, why is it called irreducible? Basically, irreducible meaning that, okay, if you're going to, meaning that for this, if you're going to let it equals to 0, right, there's no real values of x, alright, which will gives you negative 4, right, hence it's considered as an expression that you can't factorize it any further. So therefore, it's called irreducible. You can't factorize it anymore. So if that is the case, then what is the rule? So the rule is just to let it equals to ax plus b. And in this case here, you see that you can't actually do anything else. Right, you will see that your ax is equals to negative 2. So your a will just be negative 2, and then your b will just be 1. So usually for this sort of questions, it can't be just express 1 minus 2x over x squared plus 4 into partial fraction, because this itself it cannot be reduced anymore into partial fractions. So for this kind of questions, how would it be like? So usually it will be something like this, where you ask to express with another term at the denominator. It could be a repeated one, or it could be a linear one. So we're going to make our problem simpler by having a linear one. Okay, so if you look at the denominator, then it will comprise of an irreducible and then a linear. Alright, so for the irreducible, the rule is just ax plus b over your irreducible factor. And then for this linear one, since you already used the letter a and b, so the next letter available will be c, so c over x. Okay, right, so we're going to combine these two partial fractions into a single fraction. So you just have to look at the original fractions given to you. the denominator comprises of x squared plus 4 with x. That will be our denominator. Okay, look at the first partial fraction. So denominator is x squared plus 4, so we need to multiply with the x. So therefore, I need to multiply my ax plus b with x, and make sure you bracket your ax plus b, because there is a difference, okay, when you put ax plus b times x, can you see, versus ax plus b with the bracket times x. Okay, the two answers will not be the same. Okay, definitely the two answers will not be the same. Hence, it is very, very important that you put a bracket here. Alright, then for the second partial fractions, I need to multiply it with ax squared plus 4. Alright, so now we have the same denominator. Let's do substitutions to find all our constant terms for the numerator. Alright, so I think we could just let x equals to 0 so that we can just happily eliminate our constant a and b. Right, so we're going to let x equals to 0. So this full term will be gone. So left only with c bracket 0 squared plus 4, just give me 4. 1 minus 2 times 0 is 0. So c is equals to 1/4. Alright, then the next thing is that we can do substitution method. No, sorry, we can do elimination method. Sorry, we can use compare coefficients of similar terms on both sides easier. So we're going to expand it. So you will have ax squared plus bx plus cx squared plus 4c equals to 1 minus 2x. Okay, so since we've already found, okay, so what we're going to compare. Alright, so if you look at it, there's only one constant term. Oh, that is c, which I've already found earlier, c equals to 1/4. So we're going to compare our bx term. Alright, so from here, our bx is equals to negative 2x divided by x on both sides. B is equals to negative 2. Right, so we found the values of c, b. Now we can go on to find the constant term a. So we can group these two together, which is just your ax squared plus cx squared equals to 0, because if you look at your right hand side, there's no x squared term, so equals to 0. Going to divide by x squared on both sides, so a is equals to negative c. Alright, so let's put them all together so that we can get our partial fractions. Okay, so the partial fractions will be alright, a, which is equals to negative c, and c it's 1/4, so negative 1/4. So I have negative 1/4 x plus b, which is negative 2, so minus 2 over x squared plus 4 plus 1/4 over x. Alright, we can't leave answer as such, it's not simplified. So what we need to do is we're going to have use some trick here. Right, so we're going to multiply with 4 at the numerator, also at the denominator. Likewise for this also. Why do I choose 4? Because if you look at 1/4 x minus 2, okay, we're basically going to make 1/4 a integer. So 1/4 times 4 will just give you 1, which is an integer. Alright, so I have negative 1/4 x times 4, that gives you negative x, negative 2 times 4, negative 8 over 4 bracket x squared plus 4, and then 1/4 times 4 will be 1 over 4x. So basically, this is how we manage questions where we have irreducible factors at the denominator. Alright, so we have managed partial fractions where the denominators comprises of the linear factors, where the denominator comprises of repeated linear factors, and where it could be repeated with irreducible or linear with the irreducible. So another kind of problem sum could be such: express x cubed over bracket 1 minus x to the power of 2 as partial fractions. Alright, so in this case here, if you were to examine the fractions given to you, alright, if you look at the numerator, it's of degree 3. And if you look at the denominator, if you're going to expand this repeated linear factors, what you are getting would be the highest power is 2, so this is of degree 2. Right, so if the degree of a numerator is equal or more than the degree of the denominator, then this is called a improper fractions. So what do you do when you're given the improper fractions? Basically, you cannot apply the rules that we have just learned. The 3 rules that we have just learned are only meant for proper fractions. Right, so we have to do something to these improper fractions. We have to carry out this thing called long division to convert it into quotient plus remainder over divisor. All right, how do we do it? Okay, we need to carry out the long divisions process. So your dividend is x cubed, and then the divisor is 1 minus 2x plus x squared. If you've already forgotten how to do long division, please you can look at the videos I've done earlier. Okay, I can put a link at this video. Right, so we're going to multiply with the x. Right, so you will get okay, let's rewrite this. Let's rewrite it properly. As in the x squared minus 2x plus 1. That makes life easier, right? So we're going to take multiply with x. So x squared times x will give you x cubed. Negative 2x times x will give you negative 2x squared. Positive 1 times x will give you plus 1. And you will get 2x squared minus x. Alright, we can still go on to do some more divisions. We can take this guy here, 2x squared, divide by the first term of the divisor, which is x squared, gives you 2. So I can actually multiply with 2 to get 2x squared minus 4x plus 2. And then if you work it out further, you will have negative x. This is negative, right? Negative x minus and minus is positive. So negative x plus 4x will give you 3x. And then positive 2 times negative will give you negative 2. Alright, so for this case here, your x cubed over bracket 1 minus x to the power of 2 can be expressed as x plus 2, which is your quotient. And then plus, this is your remainder, 3x minus 2 over your divisor, which is x squared minus 2x plus 1. So can you see that this is a partial fraction? And this is where we're going to apply the rules that we've learned earlier. Okay, so 3x minus 2, alright, we're going to put back our linear factors, which is bracket 1 minus x to the power of 2, which is a repeated linear factor. So do you remember the rules? Yes, you have to let it equals to a over first linear factor, which is 1 minus x plus b over the repeated one. Okay, so what is the common denominator, which is this guy here? Go back to the original fractions. Okay, so the bottom will be bracket 1 minus x close bracket to the power of 2. So look at the first partial fractions. You only have one linear factor, 1 minus x. You need it to be repeated. So you need to take a multiply with second linear with the linear factor 1 minus x. And if you look at the second partial fractions, the denominator is already the repeated linear factor, so we just need to take b times 1, which will just give you b. Alright, so now we have the same denominator on both sides. So now let's compare the numerator. Okay, you can use substitutions or compare coefficients on both sides, whichever way. I think I'm just going to let x equals to 1 to eliminate my constant a. So I can find b straight away, which is just 3 minus 2, that gives me 1. And then I'm just going to let x to be 0. Put back the values I found for b. A will be negative 3. Okay, so therefore, the partial fractions are x plus 2, which is the quotient we found earlier, and then a over 1 minus x, so a is negative 3. So what I would advise you, it's not too it kind of more complicated when you have a negative first then the positive. So instead of writing negative 3 over 1 minus x, you just write this guy first because the value for b is positive. So this will be just plus 1 over bracket 1 minus x to the power of 2, then followed by negative 3 over 1 minus x. Okay, so that's how we do it. So it's save the trouble of having to take plus times minus again to convert this guy, into minus. All right. Okay, so this is a very what do you call that, quick video on how you can go about solving problems involving partial fractions. So you just do along with me. Okay, try out the questions on your own, and then I think it's a quick revision, but it's quite a comprehensive one. Okay.